Okay, so today is day 13. So the good news is today is the last lesson I will be teaching you guys. Today is the last new lessons for the course. You guys get that? That means nothing new will come after today. So basically, we are finished. Well, there's still a couple of tests coming, collimating coming, but we're finished all the material for this course. Okay. So up here you can see this is what we did yesterday, or actually down here. This is what we did yesterday, right? We did arithmetic sequence, geometric sequence, recursion formula, and series, and so on. So what we did yesterday, you guys never got a quiz on it because you guys are working on the Unit 4 test, which is the trigonomic functions, right? I hope everyone in this call did that test, submitted it on time before midnight. Okay. Let's just go, you know what, before we go any further, can someone, you don't have to, tell everybody, but send me a private That's right, I'm back. Let's continue. No, it's still recording. Let's share the screen again. Yeah, I lost internet connection temporarily, so yes, I'm back. Okay, so let's get into the lesson for today. The lesson for today is we're going to talk about money. Simple interest, compound interest, preset value, the amount of annuity, the value of annuity, and we're gonna do. You guys will do some practice questions for these lessons. Okay, tomorrow you'll get a quiz on these lessons. Okay, so the quiz today is for what you guys learned yesterday. Okay, so let's get into it. Before I go further, I want to see what you guys can see, so I'm going to change my settings here. I want to make sure you guys have access. So I'm changing my settings. Okay, so close this. Go to content. scroll all the way down to here. So we are going to July 18. The first thing we see here is simple interest. There's a lesson for that. Okay. Then we're going to talk about compound interest. Lesson for that. Okay. And then we go into annuities. Okay. Let's start with simple interest. So we got a video for that. So let us start there.
We've now come to the final part of our course, which is going to deal with financial applications.
Okay, so like you said, we're in the final part of our course.
In this part of the course, we're going to discuss such topics as interest, and we're going to talk about the different types of interest that exist. And we'll also talk about something called annuities. Both interest and annuities occur very often in our lives, especially as you get older and older and you invest money or you purchase things that are really expensive. So we're going to go over what the different types of interest are, what annuities are, and how they can relate to what will happen in your life. So before we get to there, though, we need to discuss.
Okay, so let's fast forward a little bit. So right now we're going to talk about interest, and our first topic is going to be simple interest. Okay. So interest, here's a definition. As you can see, there is the fee that is either paid or earned from borrowing or lending money. If you borrow money, you must not only pay back the original amount, but you have to pay some interest as a fee. Okay. So interest, the symbol I that represents interest, is normally calculated as a percentage of principal, which is represented by P. Okay. And the principal is also known as the starting value. Okay. So principal is the starting value. And the percentage is known as the annual rate of interest. And that's represented by little r. Okay. Let's fast forward a little bit. Okay, so now we're going to get into two types of interest. Okay, so here is the first one, compound interest, sorry, simple interest and compound interest.
Compound interest. All right, let's get to what simple interest is. Simple interest is actually very easy to calculate. Perhaps that's where they came up with the name.
Okay, so we're talking about simple interest. Between the two, simple and compound, simple is very easily to calculate. Okay. So let's watch.
It's calculated by multiplying the principal by the annual rate of interest. And then depending on how much that amount of money is in the investment, we're going to then multiply that by time. Things to note here, time we always reference in years.
Okay, so time is always in years. Okay. And that's another thing that's there. And A is the amount that we have to either, I guess if we borrow, we have to repay back. Okay.
So if the time was 5 years, the value of t would equal 5. But if the time was, let's say, 1.5 years, instead of t being, let's say, 18 for 18 months, we would say that it's 1.5 for 1.5 years.
So this is key what he just said there, right? T for time is always represented in years. Okay, it's always represented in years. So what does that mean? Say, for example, I have, because we're gonna have to, break it down sometimes into fractions. So say I said we're borrowing something for, say, I don't know, 18 months. Okay. We have to convert the months in terms of years. right? So 18 months means if we want to make it in terms of years, we would have 18 months divided by 12. And then whatever that we get there. So that would be, goes into ones, so probably 1.5, okay? And that would be years. So we have to represent everything in years, okay? When we're dealing with simple interest, okay? So if I say 3 months, well, I have to do 3 months divided by 12. And that would be the time that I put in, okay? So it's important to remember that.
Remember that it's always in years. Interest rate is always given as a decimal. So if we are
Okay, there you go. So interest rate is always given as a decimal. So if I say interest is 10%, well, 10% means is 0.1. If I say 7%, then it would be 0.07. So divide whatever number you have. You have to be able to convert percentage to decimal. So please know that.
told that the interest rate is 8%, our decimal would be 0.08. So simple interest is calculated by multiplying the principal by the annual rate of interest as a decimal and then by time, giving us this formula. Interest
Okay, so there's your formula right there, right? I is equal to P times R times T. P is your principal. Now, remember, I is interest, okay? The interest in dollars. So P is my principal, which is the starting amount. R is the interest rate, which is written in decimal. T is the time, which is written in terms of years, okay? So when I do this product multiplication, I'll get the interest amount in dollars. Now, if I want to know what is the total amount, then I have to do A would equal to my interest plus my principal. So that's what this next line is going to be. That you can see right there, right? So my interest amount I would have to pay back, total amount I have to pay back, sorry, would be the principal plus the interest, okay?
equals P plus I. Two very straightforward and easy formulas to remember.
Okay, so we're gonna go a little faster because we have to get into the more difficult stuff. So if we look at this example here, right? So you can see how much, so the question is, how much interest is earned if, so now this is where we're saying, this is how much money that he gets versus how much you have to pay back. So how much interest earned if he invest $1,200 at 5% per year, simple interest for 3 years. Okay, so this is a question where how much money he's going to get back on top of his initial or principal amount. So what you're going to do is going to be your 1,200. Let me write on the screen here. All right. First of all, this 5% is going to be your interest, and it's going to be in decimal. And it says 3 years, so that means my time is 3 years. So therefore, my interest is going to be, again, my principal. That's my principal. Times R times T. Simple, right? So we're going to be 1,200 times 0.05 times 3. So that's going to be my interest amount in dollars. Okay? I'm going to put a dollar sign. Okay? So I won't do the calculation. I'm just going to play the video, but that's how you do the calculation right there. Okay, so let's play the video.
5% per year, simple interest for 3 years. Okay, well, how much interest? So we want to know.
Okay, so I'm going to fast forward. You can see that's the formula. I is equal to P times R equals to P times R times T. There you go, 1,200 times 0.05 times 3. Okay, and that's what I wrote on my screen earlier. Okay, so let's clear that. Yeah, so there you go. The interest is 180. That's what the person earned on top of his 1200. So 1200 he put in. At the end of the 3 years, he got an additional 180 on top of his 1200. Okay. Now the next question says it's 8% for 7 months. Okay, so now you have to put the 7 months. Got to turn that 7 months as a fraction of years. Okay, so it's a fraction of years. That would be 7/12. So your time is 7/12. Okay, your interest now is 0.08, and then you'll see how much. So there you go. See the time? It's 7/12. So now my interest amount in dollars is going to be 1200 times 0.08 times 7/12 because we're looking at 7 months. And you can see he's punching on his calculator here, so you can see on the side how that looks. Right? So basically after 7 months, okay, he earned $56. Okay, on the 1200 he put into his investment. There you go. So he put down 1200 in some kind of investment, and he got $56. Okay. The next one is if the interest is 4.25%, and it's saying 90 days. Okay, so 90 days. So now you have to convert days in terms of years. So in 1 year, there's 365 days, right? So it'd be 90 divided by 365 will give you that, will make that in terms of year. Okay, so that would be the fraction for that. So let's look at that question. Okay, so we know the 1200, we know the 0.0425. Now the time is the one that's tricky. Okay, I'll play it out so you can hear what he says.
It was 7 months, we'd write 7/12. 90 days, we could assume that it's 3 months, but when we talk about days, we're not exactly sure that that's 3 months, because there could be 2 months that have 31 days and then 1 month that has 30. So that may not be exactly true. Because we know it's exactly 90 days, however, we can write this as a fraction of a year in days. So remember, a year has 365 days, unless it's a leap year. But in the financial world, we assume that all years have 365 days.
Okay, there you go. So your time is 90/365. Okay, so after 90 days, the interest the person earned, you can see the punch on the calculator, is only $12.58. Okay.
We get 12.5753. Because we're dealing with money, though, we're going to round this to 2 decimal places. So 12.5, and then that 7 gets rounded up to an 8. So 12.58.
Okay. Let's go to the next part.
Part 2 asks what amount must be paid back at the end of the lending period. So we've calculated all of the different amounts of interest, but now how much has to be paid back? Well, remember, the amount paid back is always equal to whatever your principal was, or the initial amount, plus the amount of interest that was earned.
Yeah. So there you go, right? The amount you pay back is your principal, right? And then the interest. So each of these, you got different interest amounts, right? So that's basically how you calculate that.
For part A, it was $1,200 was our...
Yeah, so we'll fast forward that, right? That's pretty easy, pretty straightforward. Let's get into something that's more complicated. Okay, so now here is something you guys may know. This is a GIC, which is a Guaranteed Investment Certificate. That's what GIC stands for. So, and this GIC is paying 6% per year using simple interest. Okay, so we want to, in the end, we want to develop a linear model, and a linear model related to the amount of to time. Basically, we're going to use this formula here. because it's a simple interest, it is a linear model. That means it's going to go up each year by the same amount because it's simple interest. When we get into compound interest, it's not going to be the same because every year you have a new principal. Yeah, you have a new initial amount. When you're dealing with simple interest, even though it's over, I don't know, let's say it's over, 5 years, you're dealing with the simple interest. That means your principal is going to be the original amount at the very beginning of the start time. Okay, so your principal is going to be the same. Therefore, each year your interest amount is going to be the same. Okay, so that makes it linear. So if you draw, you'd be basically drawing a straight line going up. Okay, so when I say linear, let me just show you what linear looks like. So remember grade 9, here's your graph, right? Linear is a straight line with this slope like this. Because we're talking about it's increasing, you know it's going to be a positive slope. Now, the increase, I'm just drawing little steps here, it's going to be the same, right? Right? Rise over run, that's what I'm showing you, rise over run. The run is 1 year, the rise is your interest increase, your interest amount. It's going to be the same each year. So if I were to plot that, I would get a straight line, okay? So we want to basically get if you remember grade 9, the formula for a straight line is y is equal to mx plus b, right? Right? And m was your slope, right? B was your y-intercept. In this case, your y-intercept would be your starting value, right? So your starting value would be the initial amount. So the initial amount here would be 500. All right. So if I'm starting from 500, then that would be my y-intercept. Okay. Then if I'm looking at my slope would be the interest that I make. Okay. So that's what we're trying to do. We're trying to come up with this model here, this line equation. Okay. So let us fast forward a little bit.
To look at. Gertrude deposits $500 into a guaranteed investment certificate, or otherwise known as a GIC. You may have put money, or maybe your parents or your grandparents have put money for you into something that's called a GIC. Essentially, it's an account that you can put money in that earns interest over time. That's different than a savings account. So you can't take that money out until that time is expired. So you'll see this come up a lot. So $500 got put into a GIC and it earns 6% per year simple interest. Part A asks us to develop a linear model to relate the amount that's in the account to time. So here's what we can do. If we're relating it to a linear model, remember linear models we can always write as y equals mx plus b. That's the equation.
Okay, so that's what I wrote there, y is equal to mx plus b. So that's what we're trying to come up with, okay? So I'm just gonna fast forward, I'm gonna clear my screen here so we can see it better. Okay, so continue. Okay, so if we're trying to come up with some equation that represents y is equal to mx plus b, again, y would be your amount, right? And m is your slope and b is your y-intercept. So let me just back it up over here, just 1 second. Okay, I'm gonna play it from here.
And the two variables that make sense for this would be to replace the y with the amount and the x with time. So now we just have to figure out what goes in here, or what's going to...
Okay, so we're saying, so now if we were to graph this, you put here y is equal to a, which is the amount, and x is equal to time. Okay, and if you remember, if we're looking at this graph, your x-axis is your time. Okay, so that's why we replace x with t. And your y-axis is actually the amount. That's why we replace y with a. Okay, and that's what we're trying to do. We're trying to, and then it's going to tell you what's your y-intercept. We know y-intercept is going to be 500, but that's going to be a starting amount. Our starting amount is 500. So he'll say that, watch.
Determine our slope. And then we need to determine our b value, which, remember, is our y-intercept, or the initial amount. So just look at the question again. What do you think our initial amount?
Okay, so what do you think the initial amount is? Yeah, it's 500. Okay, but it tells you that in the question. Now, the only thing left to find out is what is our slope. Okay.
And if we relate this formula right here to our actual amount formula, A equals P plus I, this 500 is our P value. It's our principal. So the other portion here, the mx, or the whatever is missing here for the m, has to be accounted for in the I. And remember, I equals P times R times T. So
okay, so your I is actually your slope. Okay, and that's what you're trying to calculate now. So I, we already know the formula is equal to principal times the interest rate times the time. And once you get that, then you plug it into here, and that would be the model for a linear equation. So let's fast forward. There you go. Actually, you can see this whole thing is PRT, but we're only going to look at what's the P times R. Okay.
Well, we know the principal's 500. We know the rate of interest is 6%. We don't know how much time is in there because we're going to create a linear model that is relating to time. So we're going to just keep t as a variable, and we're going to add 500 as our initial amount. And our a is here. So we can multiply this 5.
Okay, so you simplify that equation, you're going to get, that's what you're going to get. Okay, so now this is your linear equation, right? So your slope is 30. So basically if we're dealing with time as in years, every year I go up $30, you can say. I start off with 500, and then if time is years, every year I go up $30. Now the question is going to be, how long would it take for your initial investment to double? Well, the initial investment is 500, right? So to double 500, that's going to be 1,000. How long does it take to get to 1,000? If we were to use this equation, then we would set our amount A to 1,000 because we're doubling 500. Okay, and then we have to solve for t, which is the time. Okay, so now how long does it take to double? Well, when you solve that, you'll get your time. Okay, and you do that. These punches on this calculator. You're gonna get 16.7 years. Okay.
I need to figure out how long this is to the nearest month. Well, 16.6667 repeated, 6 repeated. Well, that's 16 years plus a chunk. So I know it's going to be 16 years plus some chunk of a year. And if you know your fractions very well, 666 repeated is 2/3. So 2/3 of a year is, well, how many months is 2/3 of a year? Well, if a year is 12 months, 2/3 of that is 8. So 16.667 would be the same thing as saying 16 years and 8 months.
Okay, so that would be your final answer for that. So let's stop this video. I'm going to get into compound interest. Okay, let's look at that one. Okay, let's play this one.
Money, 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 must be funny in a rich man's world.
When we were talking about simple interest in the previous lesson, it was, well, pretty simple to understand.
Give me a second, guys. It's not. Yeah, computer's a little lagging. Hold on. Okay, here we go. Yep, finally it loaded up. Okay, so here we go.
But the problem is, in the real world, most institutions, such as banks or other.
Okay, so let's back up. You did simple interest. Now we're looking at compound interest. Okay, in I want to say the real world, most things, most calculations, when you borrow money or invest is in compound interest. Is done in compound interest. Okay, so not in simplest, but in compound interest. Your credit card is in compound interest. When you invest money, it's in compound interest. Okay, so that's more real life. Okay, so here we're going to talk about compound interest.
About simple interest in the previous lesson, it was, well, pretty simple to understand. But the problem is, in the real world, most institutions, such as banks or other people that lend money, don't really use simple interest when they calculate interest. They use something called compound interest. You'll see why in a second, but essentially, using compound interest earns them more money than if they simply used simple interest. The main difference between simple interest and compound interest is that for simple interest, you are calculating the amount of interest based on what the initial amount, or the principal, was at the very beginning of the term. So if you put $1,000 into an account and it earns simple interest, let's say 5%, then you're going to calculate 5% of $1,000 every single year for the entire length of the term. Basically $50 a year.
Okay, so you can see here, okay, there's a difference here. In simple interest, that interest doesn't change per year. It's a linear model, it doesn't change. In this example here, you can see it's $50 per year. It won't change after year 3 or year 4, it'll just be $50. Now you can look at the difference with compound interest.
If it's compound interest, though, what you do is at the end of each compounding period, you adjust the principal.
You see that? There's a difference now. Your compounding interest is based on the new principal that's established at the start of the next year. Okay, so my first year, in this case here, my principal was 1,000. Okay, so yeah, the first year, the simple and compound interest will have the same interest amount, which is $50. But if you look at the compound interest, at the start of year 2, my new principal now is 1,050. So my interest rate is applied to the 1,050. So now my interest rate amount, the money amount, is now $52.50, right? So you can see it's going to change after year 3. I have a new principal, right? And in year 4, I'll have a new principal. Therefore, my interest amount would be different each year. Okay, that's a big difference, especially if you're doing investments. You can see it'll grow faster because now it's compounded. Okay.
So if the initial amount was $1,000, and then at the end of the first year, $50 of interest was accrued, For the second year, instead of calculating interest on that $1,000,
Okay, I'm gonna fast forward. He's just gonna say what I just said. Kind of running out of time. So we're gonna go into the example. Okay, start here.
the money is in the account. A compounding period just happens to be the time interval after which compound interest is calculated. You'll commonly
Okay, so this is important here, compounding period. It's basically the interval after which the compound interest is calculated. Okay, if we talk about a year, then the interest is based on that year. That's calculated and it's added on to the principal. If we're saying it's say 3 months, then that interest amount, right, whatever that is, say it's 10%, that interest amount would be divided by, if it's saying per month, would be divided by 12. And then that interest that's divided by 12 would be applied to the principal, okay? And then after the month, you'll have a new principal, okay? So then when you apply the interest for the next month, it's gonna be based on a higher principal because you're adding the interest to the previous month, okay? Because we're saying it's compounded monthly. If it's compounded, semi-annually, that means you wait 6 months, you apply the interest, and now at the beginning of that next 6 months, you have a new principal amount, which would be the amount plus the interest on top of it. And then after the next 6 months, you applied the interest on the new principal amount. Okay, so let's look at a couple examples here. Okay. I'm maybe fast forwarding this. If you want, on your own, you can go back and rewatch some of it. But I just want to get to the main points, to the main examples. Okay, so here's an example here. Okay, so you can see he wants to purchase a new guitar. He borrows $650 from the bank, which she plans to repay after 5 years. The bank is charging you 12% compounded annually. Okay, so let's look at this example. Okay, so that's the formula, okay, you use to calculate your amount, okay. The things that are the same are the principal. P is your principal. Now what's different is your N. N is your compounding period, okay. So let me back up so you can explain it. I don't want to miss anything for you guys.
that means that each compounding period is 1 year. So at the end of every year, we're going to readjust the principal to a new amount. So here's part A. Determine the amount that Helga must repay after the 5 years. Well, we've been told what the formula was for compound interest. Compound interest is equal to, the amount, I guess, after the term is equal to P times 1 plus I to the exponent n. The P is our principal, so our principal was $650. I was our interest rate calculated on a yearly basis. So because this is 12% per year, our interest rate is 12%, or 0.12.
Okay, so this is going to be an easy example because the thing is we're looking at it as principal. So we're looking at the interest that's annual. It gets complicated when the interest is not, say, annual, if it's compounded monthly, if it's compounded quarterly, if it's compounded daily, okay? So I want to fast forward through this so you can see the calculation. Okay, so our interest is 12%. So it's going to be 1 plus 0.12 gives you 1.12. And my N is, because we're compounding yearly, my N is going to equal to 5. Okay, we punch that in the calculator and we get this, the amount okay, the person will have to pay back after 5 years. Okay, so look at that. The person will have to, so the person borrowed $650, okay? $650 to buy this guitar. 5 years later, she's paying back the bank $1,145.52. Almost doubled, right? It's almost doubled than the money she borrowed. She borrowed only 650, but now she's paying the bank, $1,145. You see how the bank makes money off you when you borrow money? And that's only at 12%. That's only 12%.
$1,145. Yikes. All right, part B asks, how much interest will she have paid?
So how much interest you have paid? Basically, you're going to subtract the new amount, 1145 minus 650. So if you do that math, she would have paid back an interest amount. She basically gave them almost $500 in interest, right? It originally cost her 650, but in actual fact, she had to pay another $500 to borrow the money. Okay.
Let's recall what the interest formula was for simple interest. Remember,
Okay, so we're not going to compare to simple interest. We're just going to fast forward through that. Give me a second. Okay, we're going to talk about varying compound interest, compounding period. That's important. So let's get to the beginning of that. You guys got to get that lesson.
if questions were all like that, then compound interest would be a pretty simple process. However,
Okay, so here's your formula for compound interest up there, you can see. But because you have different compounding periods, okay? So it says here, banks and other institutions will often use different compounding periods other than annually, okay? And I'll tell you the reason why is because say for example, your credit card is using a daily interest, is using daily compounded daily. And the more compounding periods you have, the more money you end up paying. So the credit card company is doing compounded daily. So every single day they're charging you interest, and it's going back to the new principal amount, because every day is a new principal amount, right? Because every day the interest is going on top of the principal. So therefore every day there's a new principal amount. So daily is the most money they can squeeze off you, okay? Yearly is the minimum, right? So if it's say it's 13%, but it's compounded monthly versus compounded daily. If it's compounded daily, you end up paying more money than if it's compounded monthly or yearly, okay? So he's gonna explain that a little bit.
in the real world, it's not quite as easy. What we can do with compound interest is we can vary how often the money is compounded. It's not necessarily compounded every single year. So banks and other institutions use different compounding periods other than annually. A lot of times you'll see semi-annually, which means twice a year, quarterly, monthly, and I even mentioned that sometimes they'll use weekly or even daily. So when we change the compounding period, two different things in our formula will be affected: the I value and the N value. The P value, your principal, stays the same. That's just the amount of money that you initially put in. The A value, well, that's going to change depending on what your I and what your N is. But the I and the N both change. So let's take a look at this example in the yellow box.
Okay, so we're looking at this example here. Okay, as an example, assume that we invest money into an account that earns interest rate of 8% per annum for 3 years, but it's compounded quarterly. Okay, the key is it's compounded quarterly, not compounded.
We're going to invest money into an account.
It's not compounded yearly, it's compounded quarterly. So if we're looking at that, now our N is the number of compounding periods. Okay, it says here N represents the total number of compounding periods. Okay, That's key to remember, the total number of compounding periods. If it was compounded yearly, then if I say 3 years, that means if it's compounded yearly, what would that mean? It would mean that my number of compounding periods would only be 3 years, because it would only be 3 because I'm compounding yearly for 3 years. Okay. In this case here, I'm compounding quarterly. Okay. Quarterly means every 4 months. Okay. So in 3 years, every 4 months, I'm compounding. So what would that mean? I have to multiply 3 years times 4 compounding periods per year. Altogether, I'll have 12 compounding periods in 3 years. Okay.
We now need to consider, all right, instead of n being number of years, it's how many times being compounded. Well, because it's going to be
Okay, so that's what he said, which I just said that. Okay, now the next thing we have to look at, because we looked at the n as now compounding the total number of compounding periods in the 3 years, with the question saying 3 years. So we gotta look at 3 years. So we get 12 compounding periods in 3 years, right? Because in 1 year, there's 4 compounding periods. Now we gotta look at the interest rate. The interest rate normally is it's if it's compounded yearly, you wouldn't do nothing with the interest rate if it's compounded yearly. But because you are compounding quarterly, you have to now do something with the interest rate, right? The interest rate is being applied. So let's read what it says there. Interest rate, I represents an annual interest rate, or in other words, a rate charge over the span of 1 full year. Okay, since we're compounding 4 times, we must charge a quarter of the annual interest rate per compounding period. So that interest rate is for the whole year, but we have to apply or charge a quarter of that interest rate to the compounding period. Okay, so if it's compounding quarterly, that means I'm going to divide my interest rate by 4 with this 4 periods. And then my interest now would be 2% per compounding period. Okay, or we can say quarter. Okay, so that will be my new interest rate.
I represents your annual rate of interest, or how much that you're going to charge for interest over the entire year. But because we're compounding quarterly, it's not fair to take our annual rate of interest, 8%.
Okay, so I'm going to fast forward a little bit. Okay, so I just showed you there, that's your compounding interest now per quarter. Okay, here's more examples where now if we want to do comparison, let's go back and what's the difference if the bank charges you compounding semi-annually or the bank charges you compounded monthly. Same interest rate per year, but compare semi-annually or monthly. Do the comparison, right? So I want to fast forward this, you can see the comparison. And like I said, the more frequent the compounding period per year, the more you'll pay in interest. Okay, so this is monthly, this is semi-annually. So semi-annually will probably charge you less than monthly. So let's look at it. Okay, so we're looking at A, compound annually. I have 2 compounding periods per year. Okay, and we're looking at what, 5 years, right? It says 5 years. So 2 per year for 5 years gives you 10 compounding periods. Okay, now if you're looking at I is your interest rate, and your interest rate is going to be divided by the compounding periods you have per year. So my I will be divided by 2. So 12% divided by 2. So my I is going to be 6% per compounding period in that year. Okay, So here's my formula. I plug it in. I'm going to get, that's the amount. That's my amount that if I'm investing, this is now talking about investment now, right? So if I'm investing, I'm going to make my amount after 5 years is going to be what you see there, okay? And that's compounded semi-annually. And if I compound it monthly, let's fast forward. We're going to look at B, right? Monthly, my compounding period now is going to be, if it's monthly, it's going to be 12 in 1 year, right? Because I have 12 compounding periods in 1 year. If I'm saying monthly, because it's 12 months, every month I'm compounding, right? So now if I'm looking at it over 5 years, it'll be 12 times 5. So I'm looking at 60 compounding periods, okay, over 5 years. Now, if I'm looking at my interest rate, again, that's 12% per year, but I have to divide it by the number of compounding periods per year. And since we're saying monthly, we divide that by 12. So that's going to be my interest rate per compounding period, which is monthly. So I plug it into this equation here. Okay. And then you'll see the total amount. There you go. You can see that. Compounding monthly gives you more if you're doing investment. It gives you more than compounding semi-annually. Okay. I'm going to have to stop here because we're going over time. Okay, let's go back to the rest of the content. Okay, so I did not talk about preset value annuities. I didn't talk about that. What I'm going to do, because we have time tomorrow, I'm going to go through these two items here, annuities and preset value. Okay, I'll do that tomorrow. Because you don't really, you're not going to get your quiz for this anyways until tomorrow. Okay, the quiz you're working on today is based on what we learned yesterday. Okay, so I'm going to go back to the home page. I want to see to make sure you guys can access that quiz. There should be a link on the home page I put here. So here's the quiz, right? That's for today. I'm going to click on it. It should give you, let's see. Yeah, it's there. You guys can access it, and it's due today by midnight. Okay, you get, I think it's 8 questions. You have 60 minutes for the 8 questions. Okay, I'm gonna go back. So the quiz today is for, like I said, it's for the stuff we did yesterday, which is all the sequences, recursion formula, arithmetic series, geometric sequence, arithmetic sequence. Okay, that's the quiz for today. Tomorrow, you'll get the quiz for this other stuff which I just talked today. You'll get the quiz tomorrow for compound interest, simple interest, preset value, annuity, not today. Okay, so even though I didn't finish all these lessons, we'll finish that tomorrow morning. But today, you can work on this quiz. And if you've done this quiz, you can work on this worksheet, go ahead, and then go through the videos for the stuff I'm going to talk about tomorrow. Okay. So I'm going to stop sharing my screen. And this is how we end today. And guys, I will see you tomorrow so we can finish up the rest of the lessons for this course. Okay. Okay, guys, take care. See you tomorrow. Bye.